Hi, and welcome to the Wild Center's PlanetCast, streaming to you live from Planet Adirondack. I'm Rob Carr. Tomorrow, we unveil a brand new visitor experience at the Wild Center, our first major addition since opening in 2006. Planet Adirondack features an interactive illuminated Earth called Science on a Sphere. It was developed by NOAA, the National Oceanic and Atmospheric Administration, and it's the first one ever in New York State. In Planet Adirondack, we'll be able to see how the world really works. Visitors can ask questions about everything from weather, earthquakes, oceans, human population, to other planets in our solar system and beyond. And then we can watch the sphere answer in an amazing display of images and ideas. And hopefully by looking at the planet from this brand new perspective, we can better see how the Adirondacks, or the local environment wherever you may be from, directly is connected to the rest of the world. Tonight, we want to give you a sneak peek of what Planet Adirondack has to offer, during which we want to hear from you. So please send your questions and thoughts. You can do this by visiting our Facebook page. You can do that by searching the Wild Center, or over Twitter using hashtag PlanetCast. Joining me in our exploration tonight is Dr. Curt Stager. Dr. Stager is an ecologist, paleoclimatologist, writer, and professor at Paul Smith College right here in the Adirondacks. Dr. Stager can also be heard on North Country Public Radio as co-host of the internationally syndicated weekly science program Natural Selections. His new book, Deep Future, explores the impacts of climate change over the next 100,000 years on Earth. It's my pleasure to welcome Dr. Curt Stager. Thanks for joining us today.
Hi, Rob. Looking forward to it.
Help us showcase our new experience here.
This is great. Already, I like it already.
Well, let me bring up something called the blue marble. I'm sure a lot of us have seen this before, but seeing it like this is pretty amazing. This is probably the closest thing that visitors will have to being an astronaut in outer space and looking at the Earth. So as a scientist, what do you find would be the most interesting things that people can understand by looking at the planet from this perspective?
Well, one thing is when you see something in 3 dimensions, it's a really different experience from seeing it flat on a map. So this really shows you that you really do live on a spherical planet right away. And as you hinted earlier on in your comments, because you can kind of see where everything is in relation to everything else, it really demonstrates how well connected things are, especially if things start to move, which I think we're going to be doing in a minute.
Yeah, absolutely we are. And you can see there's lots of water, which is, I mean, you don't think about it. I mean, we're always on land, so seeing all that water is pretty...
Yeah, there are just some real simple things you'd pick up right away visually is how blue most of the planet is, especially when you're looking at the Pacific compared to this.
Absolutely.
Other things you'd notice too after a while is that most of the water is in that lower half, you say the southern half of the sphere.
Yeah, southern half.
Or just simple things like which way is up. Like usually when we see a picture of the Earth or a map, north is like up, right?
Yeah, that's an interesting concept. So what if I was to actually do this with the...
Yeah, now try not to get seasick, but this makes a really important point right here. That what we think of as up really is not, it's sort of an illusion based on where you happen to be living. Australians, like in that place right there, are not really walking around upside down.
Yeah, so if the preeminent map makers were from Australia, they might have actually drawn the planet like this.
Right, yeah. I mean, if you came in from outer space as an alien, you might just as well come into the Earth and it would look like this to you.
Yeah, because our up and down is relative to gravity. So
right.
When there's no gravity in space, you can look at the planet in any direction, basically.
Exactly, yeah.
Well, so I always grew up reading science fiction, and a lot of the science fiction talked about Mars, and they always kind of build up Mars as this twin planet to Earth. So I thought maybe we could take a journey over to Mars and compare the two.
Sounds good. Wow, this is amazing. Now this is what the Earth would look like without the water or the vegetation or the people.
So basically, all those pock marks too, all the crater marks, you probably see that on Earth as well?
Yeah, actually now this could be a little confusing, right? Some of these things, depending on how you look at them, look like they could be bumps instead of depressions, but these are craters here. They're going in, not coming out. But this would suggest Mars must have been hit by lots of little, comets and
Yeah.
asteroids and such. Earth was hit by just as many, but you don't see it as well because the crust is moving, it gets eroded away,
There's
the
water on the
vegetation.
planet,
yeah,
yeah.
exactly. So it's much better preserved here. This is from the earlier days of the solar system.
So it looks relatively static. Are there any changes going on Mars?
Yeah, there's one thing you could see. If you want to tilt Mars a little bit and show us one of the poles, you can see there's ice here, ice and snow, you could say, like we've got at our pole.
So there is white on the red planet here.
Right,
Yeah.
and it's less direct sunlight, so it's cooler. But now if you look at the other pole,
Okay.
if you did this on our planet,
Oh, there's a little white dot down there
you
too.
wouldn't see quite as big a difference on here. And what basically happens is the temperature changes are very extreme, and with the seasons, when this is the warm season on this end of the planet, a lot of that snowy stuff will evaporate into the air and travel around and be trapped on the other side of the planet. So the polar whiteness will change and migrate from one end of the planet
So
to the other.
one will get big, and then they'll switch, and
Yeah.
that one gets smaller.
Yeah.
So, and that happens seasonally.
Yes,
Oh, so there's seasons on Mars
they
as
have
well.
seasons on Mars too.
That's very interesting. Well, I'll go back over to Earth. I'm going to give us a different view, actually, because the last one you really couldn't see the human activity on the planet. But this is a really neat perspective. Here, I'm going to come over to the United States. This is the Earth at night.
That's neat.
You can actually see the lights glowing into outer space.
Yeah. It's an easy way to see where the people are.
It's a very, yeah, absolutely.
Yeah.
So you can see where the eastern half of the United States is pretty well populated.
Now here's the difference. This is the first time in the history of the planet that this darkened side of the planet would glow in the dark. And it's all because of us. And that's like fireflies on the planet there.
Do you think could we see the Adirondacks? Is there a little
Yeah, no.
that might be difficult to?
Yeah, it's hard to do because you don't see the state lines on there. There's Lake Ontario right there,
Yeah.
so we're in a kind of a dark zone right up in
Oh,
there.
there's a little. So
Yep.
we don't have as much light pollution as if going down.
We're not like New York and Boston and all that.
Yeah,
right?
New York is almost one solid white blob there. Yeah. Well, you look at the United States though, and then if you go over to, say, Africa,
Yeah, you can see.
that's a
where
huge difference.
Yeah, big difference, especially up in the Sahara there. Compare that to Europe.
Yeah, I'll come down and actually. Wow.
Right,
Yeah,
yeah.
that's a huge. So Africa's about what, 5% electrified?
Well, yeah, but not very much out in here, that's for sure.
Yeah, not much at all.
Now, can you show day and night passing?
Yeah,
anyway
actually,
on here?
I can show day and night, and I can do it in a really neat way. There's something else on here as well. So this shows both the day and night terminator, so as it's getting dark, but these little dots that look like bees buzzing all over are actually airplanes.
Oh, that's incredible.
And this is taken over one day, and it shows all of the air traffic in one day. So
It's like insects.
like
Yeah,
insects
yeah,
buzzing
yeah,
over. And this
yeah.
this both scared me and made me feel a little safer while flying. I think I'm going to come over to Europe now and go down because it's daytime now, so all the flights are really starting to kick in. It scared me because how are they not running into each other?
I think they're very careful about that. But isn't that amazing? It's the same way of telling where all the people are.
Yeah.
Now, I would predict there wouldn't be as much of that happening at night, right? So if we can follow where day and night
Yeah,
are
so if
on
we kind
here.
of come over to the United States, it's going to start.
Now, here's an interesting thing. Watch, there, that dark shadow there is night, and over here is day. And already, again, you can see this blue marble sort of effect that you realize that we think of day and night as a time.
Yeah.
Because we're usually stuck in one place, right? So that you say it's daytime, nighttime. Actually, though, this shows you that day and night are a place. That the day is just the sunlit side of this sphere, and the night is the dark side, and that we actually pass into them. So very strange.
As the Earth is rotating.
Yeah.
And you can I think it's kind of come over to, it's neat to see all this activity, and then as the night kicks in,
Oh yeah, can you see?
Really,
it'll close it down.
it'll start to die down.
So here's the night coming over the East Coast. These are the night flights, I guess.
The red eyes.
Now I'll bet you Europe is asleep, right? Can you go over to Europe?
Yeah, Europe.
These are the planes going across to Europe, and there's not nearly so much.
And it's going to start to kick in as it gets light.
They're all coming to Europe there.
So that's a
really
lot
interesting.
of. That's a lot of flights, and about 90,000 flights I read each day. It's amazing to actually see it like this and what kind of impact those flights might be having. That's pretty interesting. Oh, let's so one neat thing about this experience is you can see this came from data from about 9,000 airports around the world, and it collects data in lots of different ways. But one thing it does is it collects data in real time. So there are satellites that are orbiting the Earth, and they're taking pictures.
Oh my gosh.
And then organizations like NOAA and NASA are collecting that information, and Planet Adirondack is downloading it almost hourly. So things like weather, which is what you're seeing now, this is real-time weather.
This is amazing.
Or earthquakes, even droughts and fires, you can see them almost as they're happening.
This is amazing. Now, for a scientist, I would encourage my science colleagues or science students to see something like this, because we're used to seeing just a static photograph or a map or something. This way, you can actually see where the wind is coming from and where the moisture is coming from, too. Like one of the questions I often ask, where does our groundwater come from, or where does our rain come from here in the Adirondacks? Okay, so we're up here. If you watch this thing and just follow the white streaks, and looks like some of our moisture is coming right from the Gulf, and then it comes up here, but then some of it's coming from the Pacific over here.
Some of it's coming from way over in the Pacific too, like all the way.
Well, and that's the most amazing thing, as we said earlier on, everything on the whole planet's really connected, and we're not really isolated. This flow has come across from the Pacific, and you can follow it all the way around the planet.
So you can, and so it's really got this west to east, this heavy west to east kind of migration of the clouds.
And you can see that when you watch your weather reports. Most of our weather is coming from the west, but not always. Sometimes we'll get something up from the Gulf and up the coast as well. Can you look at things like hurricanes and
actually
historical events?
I can bring up just last year's hurricane season. We had a pretty infamous one. I'll come over. Hurricane Irene. You can see it forming right here. I'm going to pause.
Oh my gosh.
This is Irene forming in right in the Caribbean, in the South Atlantic, and then I'll start it up again. You can see it start to. It's coming over the Dominican Republic.
Wow, you can see it spinning like that.
There's
the eye of the hurricane starting there, that little hole.
Yep.
And now instead of going over there, it's coming up at us.
So now it slams into the Carolinas right around there.
Wow.
And I think around then it was downgraded to a tropical storm, and then comes up, and then this.
Yeah. That's incredible.
Right over the Adirondacks.
See the actual storm.
Yep, the actual storm. We have hurricane seasons for Katrina as well. You can see the origin and the path of Katrina, and you can see it goes actually all the way up to Europe, and then starts to dissipate.
Goes across here, right. Now you can see where the hurricanes come from, right? If you tilt the world up for us, you can see that they come here from the east, from actually blowing off Africa around the Sahara area. And you can see they're sort of spinning, and most of them sort of dissipate, but some of them turn into our hurricanes. So our hurricane Irene originated somewhere over the Sahara.
Wow. And you can actually, if you go back to the weather, and the way the clouds move over Africa is completely different.
Yeah, in the tropics, the seasons are different from what we think of here, where you have the warm season, the cold season, winter and summer and all that. There, it's these clouds that actually drive the seasons, and they have the wet season and the dry season instead. So here, wherever those white clouds are is where you're likely to get the rain. And notice it's over the green part of Africa, which is what makes it green. And you don't get so many of them up there in the yellow part where the Sahara is.
So weather impacts lots of different things, but one thing I would imagine it has an impact on is the way the oceans are moving. So
Absolutely.
It's another thing that you could see. I'll bring this up. A very beautiful display here.
Oh my gosh.
It almost looks like something you would see at a Grateful Dead concert, but it's
very artistic looking. But these are actual measurements of the actual currents, right?
This is the way the ocean is moving. So this is sea surface currents, and then also the temperatures of the waters as well.
Okay, so the redder it is, the warmer it is, and the bluer it is, the colder it is.
Yep. So I'll come if I come over. You can see the equatorial current across here, and
look at that.
I don't know if you saw the movie Finding
Finding Nemo. There's that current that went down
that the
here.
sea turtles used.
The sea turtles used
Yes.
that. Now look at this in the Pacific here. You can see the equator's right about in there.
Mm-hmm.
And the winds are mainly blowing this way, so that's why the currents are going. And notice how it starts out yellowish, sort of, and then it becomes redder and redder as it goes. That's because it's warming up under the equatorial sun there.
So it's coming from somewhere colder.
Let's take a look. Let's see where it comes
from.
Yeah. It'll be off South America. And that makes sense, too. It's darker. It's not nearly as red, and that's because the winds are still blowing the water away from the shore. Mm-hmm. And making cold water come up from below to replace it.
So if you follow this current, then it goes all the way across here. Mm-hmm. Comes kind of scoots around
now
Indonesia.
See how green all of that land is over there too, if that makes sense. That's where a lot of rainforests are in Indonesia and Borneo. And with that warm sea there, you get a lot of moist air and a lot of rain, and keeps everything lush.
So then, if you keep coming, it kind of slams into Africa here. Mm-hmm. And I mean, this is pretty neat. It seems to go. It can't go anywhere, so it goes around the bottom of Africa.
Yeah.
And what's going on here? So we have, seems like these giant whirlpools.
It's like it's blowing smoke rings of warm water. Yeah, there's a current here, the Agulhas current, that comes by here, and it runs against this one. Sometimes this current pinches it off, and that warm water can't get across. And sometimes when the currents are down, you can get this Indian Ocean water boiling off into the Atlantic.
So it connects what's happening over on the east side of Africa with they kind of seem to be
happening here, and then theoretically it can come up into this current, come to South America, and then join the Gulf Stream, which is that whole thing right there. And all those swirls.
So that's coming up across the eastern United States and then shooting up to Europe.
To Europe. And having that tropical warmer water makes the North Atlantic a little warmer than it would be, and the wind blowing across it helps keep Europe a little warmer than it would be otherwise too. So if you look at the latitude of where England is, or Northern Europe, it's the same latitude as Hudson Bay, pretty much.
And it's going to be a lot colder, but Europe has that warm water coming up. Yeah. Oh wow! So if you're out, can you get sucked into these whirlpools? Should you avoid them? And what? And they seem.
Well, I mean, the sailors through the centuries that really knew what they were doing would know about currents like that, and you'd save some time if you're going with a current than against it. And fishermen take advantage if you see the Gulf Stream there with those swirly things up there over by Florida again.
Yep.
Sometimes the swirls will pinch off like meanders in a river, and they'll trap tropical fish from down here and end up having a little kind of a bubble of warm tropical water going off into the North Atlantic, and you could sort of get different kind of fish in different parts of the ocean.
So fisher would actually seek these out. And they look small in here, but I imagine they're about the size of 300
Pretty
miles,
big,
about the size of Texas. Yeah.
All
right, so
that's incredible.
Yeah, this is really neat. You could probably talk about this for a while. So one thing I really liked about was this display that shows. I almost equate it to the planet breathing. So what we're seeing here is this explosion of green color is actually chlorophyll. And it's a concentration of chlorophyll both on the land and in the water.
Wow. So that would be with the seasons.
Yeah, so right now I guess you can see down here you have the date.
February, March, April, May, June. Yeah, you can see the darker green that is, the more vegetation.
The more vegetation. So actually the forest is getting its leaves, plants are coming out. But not only on land, you see it in the oceans as well. It looks like it's.
Yeah, you'll get seasons of growth of the algae as well. And of course, you'll have it different in the other hemisphere, and that'll make the composition of the atmosphere change too. So during those vegetation-rich seasons, you'll get more oxygen in the air of that hemisphere. So it kind of goes up and down, not enough that you have to hold your breath or anything, but
so
definitely.
On this, we actually have this this graph here, which is showing the carbon dioxide in the atmosphere. So you have this up and down pattern. So basically, is what happening is the chlorophyll, when there's more of it, it's taking in more carbon dioxide.
So you can see the seasons going up and down in those pulses. So the higher one would be when the plants aren't growing so much in the northern hemisphere. That's really neat.
And it does have this upward trend. It looks like the carbon dioxide is definitely increasing in the atmosphere, regardless of how much chlorophyll is being produced. So I'm going to bring us over to, this is a really neat display.
Oh, wow. That's eerie looking.
This is kind of scary. Beautiful, but this shows the green is the sulfates in our atmosphere, and the purple is black carbon.
Wow.
So black carbon is basically soot from the burning of fossil fuels. So you can't really see it, but this is China and India.
So that would be industrial pollution with the sulfur coming out of the burning of coal probably and things like that. Oh, it looks like, it doesn't look very healthy, does it?
No.
And then the blue could also be cooking fires too. It depends, or forest fires or savanna things. But that is just amazing. Now, if you look over at North America, we've got some of this going on too, right, from our own industry.
I'll bring us over there.
But you can just see how it really goes everywhere. It's
Goes
like
everywhere.
Every place is downwind or upwind of every other place.
You see there's another big pocket over it, over the United States.
Now there you can see why we get acid rain in the Adirondacks.
From
the sulfur stuff, if it combines with rain or snow, you'll get sulfuric acid. And because the winds are blowing from the west towards the east and we're downwind of all of this industry right here, that's why we get that problem right there. But notice it keeps going.
It keeps going. So it actually goes all the way up to the poles. It's over Greenland and Iceland.
Yeah. Now this is something my colleagues that work on ice cores would be interested in too, because they can find these sulfates and the black carbon in their ice cores from Greenland. And a demonstration like this shows you where the stuff comes from.
It's going right over it. That's pretty amazing.
It can come from the U.S. and then loop around and come up. It can be coming from Europe too.
What about, so if I went over to some areas that were not as populated, if I went to Africa, there still seems to be a lot of black carbon there.
Right. Now here, that's probably from brush fires. It looks like this is the month of January. That tended to be the dry season in here, and there could be, this is probably smoke, partly from people's cook fires and partly from burning brush in savanna.
Oh, wow. So you usually think of, carbon being produced by, people and
Industry
cars
or
and
something.
industry.
Yeah.
This is something that's a little bit more natural.
And once again, notice the Sahara doesn't have so much going on in it.
Yeah.
It's mostly just barren, sandy area. Yeah.
So what does this mean? I have another really interesting data set that was a little scary to me. We always hear about that the climate is warming, and a lot of it may be the result of how much carbon we're putting into the atmosphere. This is going to show, again, the planet at night. But it shows a model of what the land would look like if there was a rise in the sea level. So I can actually play this. That's a 1 meter.
So the red is what would be underwater if it goes up by 6 meters. So about, what's that,
this
20
is 6
feet
meters,
or so.
yeah.
Oh my gosh, there goes a lot of Florida.
So I can actually bring that back, and I'll pause it.
That's really interesting. So you can see a lot of the coastal areas, and the flatter ones will lose the most. The Gulf Coast is losing a lot of the East Coast over there.
Almost the entire east coast of the United States is...
A lot of that's pretty flat. They call that the coastal plain. And so, yeah, if it comes up just a slight amount, it'll go far inland compared to California, where it's steep and it won't take away as much of the land.
And half of Florida that's disappeared.
Yeah.
So is this... I mean, this kind of alarmed me. What are the chances of something like this happening in, say, your or my lifetime?
In our lifetime, you won't see it. This is something that would happen over a longer time period, over centuries, that you'll get something like this. No one knows exactly the rate, but something like that would be anywhere from 100 to several hundred years.
Okay.
So it's slow. It's not like it's going to drown you right away, but it's something we would certainly not want to have happen if we can avoid it.
So our way of life will continue pretty much the same for a while, you're saying?
Well, if you think of, like say we talk about global warming, it's a really serious thing, and we should do everything we can to try to keep it from getting, as bad as it could get. But it's also important not to give up hope. When you see something like this, you notice most of the country is not going to be underwater.
Yeah.
So it would be a mistake to totally despair and feel like we're all going to die from this kind of thing.
Unless something like this happened, actually.
Unless something could actually destroy the whole planet like the Death Star. So not to belittle the seriousness of that, but there we go. But actually, you know, we can joke about this Death Star, but there actually is a real Death Star not too far away from here.
And that would
you
be
could probably show us that.
That would be our sun.
Yeah. So actually, that will destroy the Earth sometime. That's going to be way in the far future.
Billions of years.
Yeah. Eventually, this star, which really gives the life on the planet, makes the oceans move and the air move that we've been watching here because of the heat coming from it. Someday, billions of years from now, this will get bigger and bigger and engulf the Earth and then explode. So,
but right now,
for now,
93 million miles away from us, it's the source of all life on Earth. Yeah.
Yes. Well, do you think anybody has any questions?
Yeah, so I think we should check Facebook and Twitter. I'm going to turn over. I think we do have some questions coming in. And we're going to go to Todd, and he has a question about how does the system work and how do I control it? That is a great question. I don't know if you've noticed or not, but I'm holding an iPad with me, and this is what I use to control the sphere. I can just slide my finger across it and move it around side to side, up and down. If visitors were to come to this experience, they can also try out and drive the sphere, we call it, and move it and go through different data sets. The way that it works, not to ruin the magic for anyone, is with a series of projectors that are around the room, and they project images onto the sphere. And then we have a high-speed computer that arranges these images and put them on the sphere that makes it look like the world or the sun is moving before our eyes. So that's a great question, Todd. We have a question that just came in for Curt. I've heard acid rain is an Adirondack issue. Can you tell us why?
Sure. Well, let's use this to illustrate it.
Okay.
We saw that thing with the sulfur. Let's go back just to the clouds. If you can
show even the weather.
Or how about that water vapor? Can you show that one? Or something like this too. That would work.
Okay.
Okay, so we have these prevailing winds that come from the west mostly, but not completely. And most of the sources of the acids in the rain are coming from the mainland up here in central USA and Canada. And so the winds pass over there, pick up the sulfur and the nitrogen too, makes the acids. And then wherever those white patches of clouds are, will be where the rain and the snow happens, and that's why we get it. If the Earth was spinning the other direction, and the winds were therefore blowing from east to west, California and Oregon would be getting the acid rain.
Maybe get acid rain. Yeah. We go. Okay, that's a great question. Stacy asks, is there anything about earthquakes? That's a great question. There is a great visualization about earthquakes, and it is in real time as well. So not only weather can be put on the sphere in real time, but we can see earthquakes, which is pretty neat. So we have a magnitude scale at the bottom of the sphere, and it goes from 3, which is the smaller circle, all the way up to 8.
Wow.
And this is, right now, this is coming into June, and one thing that was sort of alarming to me is California. I don't know if you have family in California, but my mom lives in California, and I saw this and I was a little alarmed.
Look at that. That's dramatic. And you can see how they're clustered in certain places.
Certain places, yeah. Right. And it actually goes, they call it the Ring of Fire. Here's the Pacific Plate. You can see all of the earthquakes that surround that plate. Yeah.
And you can actually see a lot of the cracks in the earth where one plate's going under another, or they're colliding or sliding. And that's what would make the earthquakes.
But I was amazed by how many there were. Yeah. And just for anyone that's watching from California, under a 3 or 4 magnitude are very difficult to feel. So it's not until you get to the larger earthquakes that you actually start to see the furniture shaking in the house. All right, so Susan has a question. Can this be used to show tornadoes forming so that there are early warning signs?
That would be convenient.
That would be really convenient. I think we would have a lot more people visiting the Wild Center if that was the case. But yeah, I'll bring the weather back up. The way the system works is that it takes that data from satellite, so there is a little bit of a lag of about 2 hours for Planet Adirondack to download that information from NOAA or NASA, wherever they're getting that data from. So we can't predict the weather, but we can see it almost as it's happening. So this is another question for Curt. As a scientist, how do you envision using this?
Oh, I can think of a million ways to do this. My brain is going a mile a minute with this stuff. To me, I think if I was going to boil it all down, just to see these things that you may have heard talked about in a classroom or read about in a book, to see them actually happening before your eyes is a whole other way of learning it. And I feel like I'm learning by the second, watching where the things go. And I think if there was one take-home lesson I get from this, is the connectedness of everything. So that when the winds pass over us here in the Adirondacks or just some other place, they keep on going.
Yeah.
And really, anything we do here is going to affect the winds, let's say, or the ocean currents, and affect things downstream. And then vice versa, it'll come around you again on this closed planet.
And the great example of that is the just how this is the tsunami, the earthquake that caused the tsunami in 2004. You can see where it's going to start right here, right to the east of India, and you can watch the ripple that caused.
It's amazing. Now, see, here's another teaching tool. You can illustrate current events with something like this too. So if we had this after this tsunami disaster, you could explain to people where it came from.
Yeah.
Like we just did with Irene, where did it come from? Why did it do to us what it did? So that's the most amazing thing, is these aren't just simulations. This is the actual Earth
really
doing
stuff,
what
yeah.
it really does. Yeah.
So it's a good question. Steve asks, how many different things can you show with Science on the Sphere? There are literally hundreds of different data sets. There's 82 installations of Science on the Sphere around the world. We were the 82nd, and all of those organizations that have Science on the Sphere also create content for it. So they have networks of their own scientists and researchers, and they'll create their own data sets based on that research. So there's new data sets being produced almost on a daily basis. So on top of the 350 that already exist, there's more and more being put into the pipeline. So every time that you were to visit this experience, you have the potential of seeing something new. I'm going to take one more question. This question is from John. Can it show water vapor or Doppler? That's a great question. I'm not sure about the Doppler. I'm not sure about that, but it can show water vapor. And I don't know if I have it on here loaded, but I think I can load it up pretty quick, and it will show what that water vapor looks like and how it moves. It's kind of it's going to turn the whole
There you go.
The whole globe
that's
gray.
amazing.
But the neat thing about this is,
Look at that. It
So
looks
you
like
can
a big
see-
fog swirling around.
yeah. So I was amazed by this because there's a lot of places where there aren't clouds here, but there's still water vapor. So water is everywhere on the planet.
That's right. The air is always full of it, and you just kind of notice it when it's condensing and falling out from clouds or things. You can see it boiling up over here too, probably from thunderstorms and things, and getting denser, or just being more dispersed up there where you wouldn't be able to see it at all.
Yeah, that's really neat. This is a really kind of awe-inspiring data set. I like this one.
That's a good way to see the winds, actually, too.
Yeah, the
then,
way
so
that
much.
the winds
Yeah,
are moving.
yeah.
And water vapor, if it's in our atmosphere, must be a pretty powerful greenhouse gas as well.
That's right. Yeah.
All right, well, thank you very much for the questions. I think we're just about out of time, but I want to thank everyone for tuning in. I hope you enjoyed your sneak peek of the Wild Center's brand new experience. Curt, thanks so much for joining us.
My pleasure. This was
It was
great.
very enlightening. So throughout the summer, we'll be offering Planet Adirondack guided programs and shows on a daily basis. In addition, naturalists will be available to help you explore this new experience throughout the day and even give you the opportunity to control it yourself. If you're in the Mountain Lake PBS viewing area, tune in to Mountain Lake Journal tonight at 8 p.m. to see Jack LeDuc's story on Planet Adirondack. He's going to be with a second grade class watching them as they experience Science on the Sphere and Planet Adirondack. They're from Tupper Lake. It's LP Quinn School, so that should be a really neat story. You should check that out. To find out more about membership of the Wild Center, you can visit our website. It's www.wildcenter.org, and you click Belong. We're interested in hearing your comments about the PlanetCast, so make sure to submit your thoughts and more questions over Twitter and Facebook using the hashtag PlanetCast. And we'd love to hear your ideas for future webcasts. And then don't forget to visit this season and experience Planet Adirondack for yourself. In addition to the programs that we have here, we have lots of other experiences, lots of other programs, exhibits. So make a day of it and come visit the Wild Center. But thank you very much for tuning in, and I hope you have a lovely evening and a great night.